Okay, I think we should make a start now. So, hello and welcome everybody to this last webinar in our EU Data for the Ocean Decade series. My name's Neil Fletcher and I'm Digital Media and Outreach Manager at EUMETSAT here in Darmstadt, Germany, here in rainy Darmstadt, Germany at the moment. And it's a great pleasure to be jointly hosting this session with my colleague Angeliki Karamparuni, who's Communication Lead at the EMOD Secretariat. Before we start, I'd like to thank the EU Copernicus Programme for funding this webinar series, and also our co-organisers from the Copernicus Marine Service, from EMODnet, the Early Career Ocean Professionals, and also acknowledge the support of the UN Ocean Decade Data Coordination Office. A few words on logistics, just to remind you that we'll be recording this session so we can put it on YouTube later. And if you have any questions, please use the Slido link and we'll have a look at the questions at the end of each of the sessions. And also just to let you know that we'll make all the presentations available afterwards. We have a resources section on the EU Data for the Ocean Decade website. And yes, so you can ask questions in a 10-minute break. So if we go to the, now to the agenda, the aim today is really to help you work with ocean data in ways that will support the Ocean Decade challenges. And so for this last webinar, we're focusing on the challenges related to the global ocean observing system, the digital twins and ocean literacy and citizen science. And I think we've got a great lineup of presentations today for you. So what we're going to do is we've got the three sections. So the first section will be on the global ocean observing system. Then we'll have, after that, we'll go to the digital twins section, and the ocean literacy and citizen science section will be the third part. And basically after the ocean observing session, we'll have a short break, and I'll hand over to Angeliki, who'll take over as moderator for the second part. And hopefully through all this, it'll give you a really good overview of the range of data and information that's available to support work on the Ocean Decade challenges. So now, if we go over to Dr. Adam Ledbetter, who's lead manager of the Decade Coordination Office for Ocean Data Sharing, for a short intro to the Ocean Decade. Thank you. Over to you, Adam.
Yeah, thanks. And thanks everybody for joining us. And I'd like to welcome you all as well to this webinar. My name, as has been said, is Dr. Adam Ledbetter. And in the context of the Ocean Decade, then I'm leading one of the 13 coordination offices in the decade, with a particular focus on ocean data sharing. So the Decade Coordination Offices and Collaborative Centres are the decentralised structures which provide regional or thematic coordination of the outcomes of the decade. And I think what we're going to see in the session today is echoed in the decade. So within the decade, the thematic coordination bodies have a strong relationship along a chain that goes from observation to data to products. And that we're going to hear a lot about that in the session today from partners in the decade focused on implementation or as projects and programs within the decade itself. So for those of us who work within the decade, it's really easy to just get lost in all of these challenges and all of these phrases that we use to describe the decade. But I just wanted to give a couple of minutes to help position ourselves and show what the decade is working on. The decade has this ambition to go from the ocean that we have to 2030, the ocean that we want to have. And the way the decade is organized, then there are over 600 programs, projects, and activities, and then a whole other array of contributions as well. one of the things that's really interesting to me is that the programs, the projects, the activities, they've been labeled as actions. And so these actions, they're about doing something that helps us to address one of the 10 challenges that the decade is looking at. And yesterday, I participated in the All Atlantic Ocean Research and Innovation Alliance side events around the forum that's happening in Brussels at the moment. And one of the items that came up in the side event that I was participating in was communicating why. Why is it important to observe the ocean? Why is it important that we manage the data from the ocean? Why is it important that we build tools like digital twins, like the models, the forecasts around the data that's come from observations? And for me, the first 6 challenges of the decade really kind of focus in on the why. Understanding and beating marine pollution, protecting and restoring ecosystems and biodiversity, sustainably feeding the global population, developing a sustainable and equitable ocean economy, unlocking ocean-based solutions to climate change, and increasing community resilience to ocean hazards. And then as we focus in today on expanding the global ocean observing system and creating a digital representation of the ocean, those are our foundations that help us answer all of those questions, that help us to go to these why. Why is the decade so important? And then on top of that, skills, knowledge, and participation for all, and restoring society's relationship with the ocean. If we can answer some of those whys from the first 6 challenges, underpinned by solid and sustainable ocean observing, with an accessible digital representation of the ocean, we're going to provide new skills and provide new knowledge and allow others to participate in the ocean. We'll inspire people to be involved in the ocean, and we'll restore society's relationship with the ocean. I think one of the key items of work that we're doing in the Decade Coordination Office for Ocean Data Sharing is working with national decade committees and national oceanographic data centers to enable flow of data to national and regional data infrastructures. One of these regional infrastructures is the European Marine Observation and Data Network, EMODnet, and it's great to see that they're well represented in this session. And EMODnet is also a decade implementing partner who we work closely with to put into practice the recommendations and the vision of the decade around data. The decade is also aiming to grow public and private partnerships, and that's one item that I spoke about yesterday in the All Atlantic Ocean and Research Innovation Alliance. And we're going to hear from one of my colleagues in the decade's corporate data group about the role that data collected by the private sector can play in helping us to achieve the goal of the ocean that we need for the future we want. Our own Decade Coordination Office is actively engaged in helping to achieve this goal and has supported the development of data sharing guidelines from private sector industry for bathymetry, for marine megafauna, and we're looking at expanding that into new areas. And then I think, although we're kind of focused on the first part of the session, after the break, as we see the talks move from observation to modeling and knowledge exchange, we'll shift our focus more to some of the areas of digital twins and ocean literacy and citizen science. The decade has endorsed a digital twin of the ocean program, and well-organized digital twins support much of the vision of the decade of producing a comprehensive and accessible digital representation of the ocean by 2030. Some of the ocean literacy and citizen science efforts are also key to connecting people with the ocean and restoring humanity's relationship with the ocean. When we hear later about the European Atlas of the Seas, a well-used tool that's been developed by the European community, it provides general access to the general public, including educators, with simple access to data and information about the ocean to inspire the next generation of marine scientists, as well as to provide that information to many other people. one of the tools that our vision for 2030 of this digital representation of the ocean, one of the tools that we're looking to build is a similar atlas at a global scale to help engage and communicate around the outcomes of the 10 challenges that are on the screen. Again, some of the people you'll hear from later around citizen science, we're working from our Decade Coordination Office to produce a guideline for sharing the data collected by citizen science programs to the global ocean data infrastructure, making it available to the digital twins that we will hear about for the applications that we will hear about as well. So I don't want to keep going for much longer. I just want to thank again the organizers for this opportunity to kind of put the context of the decade before we hear from the interesting lineup of panelists that we have for today and what promises to be an exciting webinar. And yeah, thank you again for the opportunity. And I'd like to hand it back over now.
Okay, brilliant. Thanks, Adam. That's a great introduction. So next on our list of speakers, we have Pierre-Yves Letran, who's Scientific Director at Mercator Ocean International and a member of the European Ocean Observing System Steering Committee. And he's going to present an overview of the European contribution to the Global Ocean Observing System. So over to you, Pierre-Yves.
Thanks a lot. So I will start to share my slide. Is it okay?
Yep, that looks good.
So thanks a lot. So I'm very pleased to be here today with you. I'm the scientific director of Mercator Ocean International. I'm also deeply involved in the European Ocean Observing System and its development as a member of the steering committee. On my activity at Mercator, also in charge of the program management for the Copernicus Marine Service, which plays a key role in the value chain, going from observation to services and users. So just starting with one slide to remind what is the Global Ocean Observing System today. So this is an international program which is led by IOC, Intergovernmental Oceanographic Commission. So it goes from the global ocean down to the coastal, from physics, biology, chemistry to biology. That's an integrated system. So we are dealing here with observation in situ, but together with satellite, and then organizing the link with modeling. The system is developed in response to societal needs, so climate, ocean health, ocean services, weather. And the implementation is based on the concept of essential ocean variables, and also the concept on feasibility maturity. So we go from a concept to pilot to mature phase, where we have the different networks of the goods that are developed. So goods today, so this is taken from a presentation from IOC. This is 84 countries, more than 8,000 observing platforms. There are 13 global observing networks on other emerging ones, on new techniques to observe the ocean. There are activity on a new active biology and ecosystem essential ocean variable. So it corresponds to more than 120,000 observations per day. This is organized with national focal points. So this is where we have representatives from countries that implement the goods, and with regional coordinations through regional alliance. Okay, just one word on because this will be discussed later. So I was mentioning it's an integrated system. So the GOOS is mainly focusing on in situ, but taking into account the complementarity with satellite observation. So here again, international cooperation is key. I mean, through CEOs and other which links together different space agencies. On the satellite, they play a prominent role in our capability to observe the ocean. So sea level, ocean current, sea surface temperature, ocean color, sea ice, waves and winds, and more recently on a really sea surface salinity. Just one point, and this will be covered later on in this webinar. I mean, the role of models. I mean, there are essential links in the value chain that goes from observation to application and users. I mean, they really transform in situ and surface observation from satellite into four-dimensional ocean fields and forecasts. And this is one of the most direct route to best serve applications. So one word on the European Ocean Observing System, which is an initiative which is organized by Eurogoose and the European Marine Board. And this is really trying to bring together all actors involved in ocean observation in Europe with the objective to enhance coordination and collaboration. So the objective is to have better coordination of the observing effort, to maximize the value and benefit of ocean observation at the national, regional, European, and global level, because Europe is also has a strong contribution to the global ocean observing system, and to have an alignment of different national activities to strengthen the value chain. So this is, if you go on our EOS websites, we have the strategy, which is outlined, the implementation roadmap, and this is an important effort of the different actors in Europe involved in ocean observing. So this is the way it works with really the objective is first to develop a shared vision and strategy for the European observing system, co-creations to meet the user needs, sharing of knowledge on best practices, working together and develop European framework, on working then with all the different elements that contribute to this European observing system, that are marine research infrastructure, different national systems involved in ocean observation. Just a few slides to outline what the European contribution to the global ocean observing system. So first, starting with satellite observation. So we do have a unique contribution, in particular, as part of the EU Copernicus Programme on all the Sentinel missions that I will not detail here, but which is really a very impressive set of satellite missions to observe the ocean. We also have the meteorological satellites from EUMETSAT, of course, part of this webinar on organization, and also all national agencies that develop their satellite activities either directly alone or in cooperation. Moving to the in situ observation, which is more the focus of this presentation today. So the way it is organized in Europe, so this implementation is done by member states, either through research infrastructure or through operational networks, monitoring network for environment, but also for meteorology and on other operational purposes. Europe contributes as well to international coordination. So I mentioned GOOS as a start, international program. GOOS has 3 observation panels, one from physics, one from biogeochemistry, and one from biology. And we have a contribution of European experts in those panels. We have the EuroGOOS, which is a European GOOS Regional Alliance. We have also the Ocean Hubs, which is part of GOOS, which is to monitor the status of the global ocean observing, which is hosted in France. We also have very important European coordination, which is done through European research infrastructure. Just I name the most important one here, and also EuroGOOS with the activity to coordinate ocean observing. And there is the objective to go towards an overall better coordination at European level with the European Ocean Observing System, which at the present time is mainly working with all these actors of the ocean observation to improve the coordination and improve the observing system. Last but not least, which is and this will come later in this webinar. I mean, all the in the value chains that all the European data and services on focusing on what is organized at European level today. I mean, it's really the 2 pillars on EMODnet and Copernicus Marine that are organized now together with the European Digital Twin Ocean. So we already have this key component of the service here with these 3 components. Copernicus Marine will not detail here, just we celebrated the 10th years anniversary, so it's really an operational EU global on regional ocean monitoring and forecasting service on observation play a key role in this in the Copernicus Marine. So this is why Copernicus Marine worked both with the European Commission, ESA and EUMETSAT to design the future satellite mission and for the institute to strengthen the development of the global and regional in-situ observing system that is really essential for the services that are provided by Copernicus. One word on the digital twin ocean. So this will be discussed, presented later by Zoe. And just to mention here that observations are also at the cornerstone of DTOs, and they serve key functions such as model calibrating, optimizing, or initializing model, training machine learning, or assessing, evaluating the information provided by DTO. So it's very important to realize how important the observations are for the DTO. So concluding remark, I mean, we have world-leading European marine services that have been developed in Europe over the past 10 years. So Copernicus Marine, EMODnet, the European Digital Twin Ocean now brings together these services, adding new services essential to sustainably manage the ocean and adapt to climate change. All these services depend critically on observation, and we know there are risks on the in-situ component today due to strong dependency on the USA. So we need actions, I mean, at the European Commission level, at a member state level, to reduce this risk and develop further European contribution to goals. There is a lot of expectation, I mean, for the coming years with the European Ocean Pact, which was announced by the President of the European Commission, and the Ocean Observing Initiative. That's all from a short overview of the European contribution to the global ocean observing system. Thanks a lot.
Okay, that's great. Thank you very much, Pierre. That's a really good overview of a huge amount of work on ocean data collection and services. So it was good to see all that. Okay, so next we're going to hear from Louis Demagne, who's the key account manager at Fugro, and he's going to talk about how they use marine data and how it can contribute to the Ocean Decade.
Okay, yes, thank you very much. And I'm hopefully sharing my screen, put it in presentation mode if it wants to. Let me just change that over. Can you see that okay?
Yes, yeah, that's good.
Perfect. All right. All right. Well, first of all, thank you very much to the team at EMODnet for inviting me to present in this webinar series for Data for the Ocean Decade. So I'm Louis Demagne. I'm with Fugro. Fugro is a global geodata specialist based in The Hague, Netherlands, but with a presence in more than 50 countries around the world. And what I'd like to do in this short presentation is to give you a bit of an industry perspective on challenges and opportunities of ocean observing, ocean data collection and data sharing, and what are some of the initiatives that Fugro is involved in to address these issues within the framework of the Ocean Decade. Sorry, I need to go back up here. Okay, here we are. I was the wrong starting presentation. All right, so for those who are not familiar with Fugro, we collect ocean data for a living, and we've been doing that for more than 30 years. But then we transform this data using science, the science that comes from the scientific community. We apply that in an operational environment to transform this data into insights that our clients then use to make more informed decisions on how to manage their assets, whether that's a built-up asset such as a wind farm, an offshore wind farm, or a submarine cable, or be it natural assets such as a mangrove or a seagrass meadow. So to do this, we operate a broad range of technologies from seabed to space, practically, with crewed and uncrewed surface vessels, ROVs, underwater autonomous vehicles, met ocean buoys, and so on. We do a lot of planning when we go out on a mission. For example, some of these vessels have 30, 40, 50 people on board. We do a lot of mission planning to ensure that, well, first of all, our staff and our crew stay safe, but also that the mission is as successful as possible. And we do that using a variety of publicly available data platforms, including EMODnet datasets, Copernicus Marine Service products, and other platforms. And we mix that in with our own experience, our own operational experience, so that we can make sure that we minimize the operational risk and, again, ensure the safety of our crew and the success of the mission. But we have seen a number of challenges and opportunities, right? The ocean is vast, and there are huge data gaps in terms of spatial temporal domains, but also in terms of the variables we measure. So I just wanted to highlight a few that through our experience we've been able to identify. Well, first of all, operational challenges, right? It's incredibly tough to acquire data in the ocean. We have a lot of people on board vessels. We have expensive equipment, and despite the best of planning, weather can change rapidly. Equipment can fail, and sometimes we're 5 or 6 days away from safety. So even with the most thorough preparations, conditions can change rapidly. So it's extremely hard. And we know Fugro is by no means the only company acquiring data there. But that is obviously a challenge. And so balancing that with what are some of the opportunities, clearly the rise in robotics offshore is an avenue that we're exploring along with many others. And that offers the possibility now of potentially having 24/7 ocean acquisition, with uncrewed surface vessels that are operated remotely from the shore. And so there is, again, we're taking people out of that hostile ocean environment, but also being able to, perhaps with a whole flotilla of some of these uncrewed vessels, being able to acquire data on a continuous basis, as long as conditions are favorable. Another challenge we see is the regulatory environment, and it's often lagging technology developments. So an example is we are still unable to operate some of our uncrewed vessels in certain countries because the regulation is just simply not there. So we can't obtain a permit to operate these vessels without our crew, even though we would be perfectly ready to do that. So that's just one example. But also, I think in terms of data sharing, if I pick that one, there's also a lot of well, UNCLOS doesn't really have very clear regulation on data sharing. It talks more about activities than data. And so it's left really to the national governments, and a lot of them do not have specific regulations to encourage data sharing, although that has been changing at the European level with some regulations coming out there. But the opportunity that we do see in terms of regulation is some of these recent global agreements that have come out, and that do provide an opportunity for that are all the High Seas Treaty, the Kunming-Montreal Framework Agreement, all of these, as they are implemented at the national level, will require data as a baseline, but also data to monitor and model these protected areas. Last but not least, I'd say lack of investment, but perhaps more than lack, it's very scattered investment. And so, and this is obviously investment in data acquisition, but it's also, I would say, investment in startups that may look at developing slightly lower cost type of technologies that could also be very, very valuable to science. I understand from these startup companies that it's often very difficult for them to secure investment because it's difficult for them to show a 3 or 4 year business plan with a steady a stream of revenue. So that's one aspect. But on the plus side, on the opportunity side, to balance that, we are also, in speaking to clients, seeing more and more that our clients are understanding that the changing ocean environment is also already starting to affect their business models. If you think about insurance companies, but also energy companies, if they want to invest in a wind farm, and we know that the frequency and intensity of storms is increasing, how does that affect their business models and their investments? So that is also an opportunity that will drive ocean data collection acquisition. So I just wanted to set the tone. So what are we as Fugro and with peers doing about this to kind of address some of these issues. So Fugro for a number of years has been involved in, I'll just mention two programs. We're a proud partner of EMODnet, of course, I wanted to mention that, but we're also, since 2017, have been contributing in-transit bathymetry data that we collect when the vessel goes from port to project area to the Nippon Foundation JEBCO Seabed 2030 project. And I think we've contributed close to 3.5 million square kilometers to date of bathymetry data to that program. But how about what can we do to also bring others with us? And that's where we also decided to partner with the Intergovernmental Oceanographic Commission of UNESCO, and we are seconding a full-time Fugro expert to the Ocean Decade Coordination Unit to help with data strategies, but also engaging with private sector to look at how can we unlock private sector data. So with that, I'd like to focus a little bit on one of the actions specifically within the Ocean Decade that Fugro has been driving with IOC. And this is the establishment of the Corporate Data Group. It's an informal working group within the Ocean Decade, but we've managed to convene 10 industry and private sector participants from different industry sectors. We've got telecom, fisheries, and energy represented there. And the goal of the group was to understand what are the obstacles today to share their data and what can we do about it? What strategies, what pathways can we facilitate can we put in place to facilitate the sharing of privately owned data? And so we've reached a number of interesting milestones in the work of the group since the 2.5 years or so that the group has been in place. One of the first ones, which was in this time last year, was that we published a bathymetry data sharing guideline. So what we very quickly understood was that different types of ocean data require different or have different obstacles. And so we needed to take them almost one by one and walk our way all throughout the process to be able to understand what are the best pathways for sharing bathymetry data. So this guideline explains, first of all, why it's important, why bathymetry data is important, and then kind of goes through kind of a decision tree almost to explain to industry, but also other organizations with data, how to share that data and what are the options to share that data. And we're currently working on another guideline on marine mammal and megafauna observations. Many of these companies here and in industry collect MMO data in some way, shape, or form. And so we are going to publish soon a guideline on how to share that kind of data. And the other important milestone, which is as a result of these first few guidelines that we developed, is that we also soon came up to an obstacle where, despite the willingness of some of these private sector companies to share their data, of course, they're saying, I'm happy to share that data as long as it doesn't require a huge amount of time and resources on my side. Well, that's a problem we can address, for example, with automated APIs and things like that. But the other obstacle was that often this data is collected in an exclusive economic zone of some national jurisdiction, and they need the green light from those national jurisdictions to share. And that green light is difficult to find, one, because it's difficult to find who actually is going to give that green light within that national government organization. And often when that person receives the request, it's not necessarily well understood. And so the easiest answer is to say, well, no, we're not going to do that. So we came up as a group and in collaboration with IOC with a policy recommendation that was presented at the last General Assembly of IOC to all the member states and was adopted. So this is not a binding text, it is a recommendation, but it does form a good foundation for us to go out and encourage national governments to implement it. And what we're saying in that recommendation is to implement policy that would make data sharing mandatory, for example, as part of a permitting or licensing process to exploit the seafloor in that EEZ. So recommend that you investigate that, because it is something that we really want to try to push. And then last word I wanted to say about the corporate data group is that, again, there's just 10 companies. What about the others? We are trying to go through industry associations to drive that data sharing forwards. So that's all I would like to say. But the Ocean Decade is always intended as a transformative process to increase our scientific understanding of the ocean, and through that process to establish new collaborations towards data collection and sharing. And the work of the corporate data group is really helping to build bridges with industry and bring them into this once in a lifetime effort to increase that data collection and sharing. So thank you very much.
Thanks, Louis. That was really interesting. And there's a huge amount of data available from the private sector, and it's great to see the initiatives that you're involved with are helping to make it more widely available for people. So it's really good to see. So good luck. Okay, so now we've heard about how Fugro are contributing to understanding our oceans, and now we're going to hear from Kate Larkin, who's head of the EMODnet Secretariat, about their role in the Global Ocean Observing System and also the Ocean Decade Initiative. So over to you, Kate. Thanks, Louis.
Thanks very much, Neil. And good morning or afternoon to all of you, wherever you are in the world. Thanks for connecting. So in my presentation today, I'm going to give you an overview of the European Marine Observation and Data Network, which was a European Union in situ marine data service. Let me just put this into presentation mode. Okay. So I will be introducing EMODnet as an EU in situ marine data service, giving you some highlights of how EMODnet is already connecting and contributing directly to the UN Ocean Decade, with a focus on the challenges that are advertised for the webinar today, and also talking a little bit about EMODnet's contribution and complementarity in the wider marine data landscape. So the complementarity with Copernicus Marine Service, but also the fact that EMODnet and Copernicus Marine are two marine data services and assets for Europe that are both underpinning the European digital twin of the ocean that we will hear about later as well. So to kick off, in a nutshell, this is what EMODnet is today. It is a European Union data service. As I said, it is on the Europa domain. So it's an official European Commission portal. And in that portal, in one single place, you can get access to marine data from the environment, from human activities at sea, across 68 different parameters, which are broken into 7 thematics for ease of discovery. And you can either dive straight into a metadata catalog, if you're more technically minded, to really search the full breadth of the catalog, which has thousands of different data layers. Or you can start in a map viewer where you can visualize and discover and then download the marine data and products that you would like, including selecting a specific region of interest and pull all of the integrated data that is available from that region. So what types of parameters does EMODnet offer? I mentioned the number of parameters, but you can see just in a nutshell, it's from the coast to the open ocean, from the surface to the sea floor. There are particular areas of evolution where EMODnet is actively working and will continue to work to fill gaps, not least at the coast, which is increasingly of societal relevance and interest for coastal resilience, vulnerability, for example, but also the blue economy that operates predominantly there. But also the deep sea, which has very few ocean observations in the first place. So we need to be bringing all of those existing data together and making them harmonized and standardized in one place, or in harmonized data layers that can be then useful as marine knowledge to underpin policy, to support the blue economy, etc. And EMODnet has been working the past 15 years on open data. So it's really been a trailblazer in the open data for the marine domain, and it's working across many different organizations to make this happen. I will come to the partnership of EMODnet in a moment, but just to say that EMODnet is really driven, and the foundation of the service is the in situ ocean observations. And Pierre-Yves already mentioned this in his presentation. You have the satellite and remote sensing community, which are groundbreaking in the global coverage that they have for the surface ocean. But as we know, the ocean is very deep, it's three-dimensional, and we really need to complement satellites with in situ observations to have this integrated offer and to really expand the diversity as well, because in situ parameters are much more diverse, at least at the current point of time. And there are many different platforms and sectors actively taking in situ observations, which can be very useful. And that's why EMODnet exists, to bring all these together and provide a service to transform these primary data into harmonized data and data products. The partnership of EMODnet is also as diverse as its parameters and the service itself. So we have 130 partners across Europe. That's 21 EU member states, but 12 associated countries as well. And within that, we have hydrographic organizations and national hydrographic organizations, the geological surveys, the national oceanographic data centers, private sector, and more. And we have an associated partnership, which Louis mentioned, with Fugro as one of the members. Now, in terms of EMODnet for the decade, EMODnet is a United Nations Ocean Decade implementing partner for some time through its democratized access and provision of fair data and marine knowledge that is also harvested and made available through global initiatives, including the Ocean Data 2030 initiative of the UN Ocean Decade. But particularly today, I'm going to discuss the 4 challenges that are the focus of today's webinar. So in terms of sustainably expanding the global ocean observing system, you've heard from Pierre-Yves, and I also mentioned the need to fill gaps in situ ocean observation, and Goose is pivotal to delivering this. EMODnet has a primary focus on data of EU interest, but that's increasingly global, and some of the EMODnet thematics already offer coverage beyond European regional seas. One example I have here is EMODnet Biology, which is really powering a lot of the marine biodiversity data management that is then fed into EUROBIS, which is a European component of the global biodiversity information system, OBIS. So this is where EMODnet partners with international organizations and initiatives to make a global coverage available to its own stakeholders. Then just to mention as well that some EMODnet thematics as well are offering unique data layers and data products for other areas beyond European regional sea basins, and that includes EU overseas countries and territories. We have an example here from the Caribbean Sea, from EMODnet seabed habitats and human activities, but also geology, bathymetry, other thematics are also working in this region, and there are other regions also. Then in terms of where EMODnet's data is also visible and increasingly used, EMODnet is one of the core pillars of marine data and marine knowledge for the European digital twin of the ocean, which will be discussed in more detail later. But just to say that the users of EMODnet are also using EMODnet very widely. We have 160,000 users to date per year. And that is increasing as policymakers and national administrations and the likes of non-governmental organizations, private sector and research increasingly use EMODnet for the purpose of foundational marine knowledge. But then all of that knowledge is offered through the cloud now through the European digital twin as well. So it can also be used for the likes of ocean modeling and prediction. And in situ here is very, very relevant because you need high volumes of these marine and coastal data for conducting the modeling to produce more accurate ocean prediction. And that can't be done alone by one type of data. So we've moved into the challenge 8 already, but here in a nutshell is EMODnet's current contribution as well to the UN Ocean Decade challenge in this area. So EMODnet is in direct partnership with many of the Ocean Decade coordination offices. We've heard today from Adam from the Ocean Data Sharing, but also the Ocean Observing and Ocean Prediction coordination offices, among others. EMODnet is the partnership, and the experts are providing advice and active engagement into these activities. Then in terms of EMODnet's contribution to global data initiatives, I mentioned the ODIS of the Ocean Data Initiative of IODE, but there's also the Global Earth Observation System of Systems that has a metadata catalogue, which is globally and publicly used. and EMODnet is also now harvested and visible there. And then EMODnet actively contributes to global repositories on ocean best practices and to the development of the global Ocean Decade Data and Information Strategy, which is already released. And then through the combined partnership with Copernicus Marine and the European Digital Twin, the EU is contributing to the global digital twin of the ocean, such as the Ditto initiative. And then I've combined Challenge 9 and 10 to move on to wrap up. First, we have the skills, knowledge, technology and participation for all. And then we have the restoring society's relationship with the ocean. These are very connected. EMODnet actively organises capacity building and training, also in collaboration with global initiatives like the Ocean Teacher Global Academy of IODE. But also in terms of working to fill gaps in the in situ marine knowledge, EMODnet engages a lot and increasingly with not only the private sector, but also non-governmental organisations. We had a workshop earlier this week with a number of key NGOs to see how they already use EMODnet and how they are providing data to EMODnet, but also citizen science and participatory science, the likes of scuba divers and outdoor ecotourism, water sports and ocean races and professional yacht races. They're all collecting data now, and they're all very relevant to bring into the marine knowledge foundation for the likes of the digital twin. And then in terms of EMODnet and ocean literacy, you'll hear more later on how EMODnet provides its data to the European Atlas of the Seas. So I'll leave that. Thank you for your attention, and a warm invitation to all of you to come to Brussels at the end of November for the EMODnet Open Conference, which is back-to-back with the Digital Ocean Forum, where you'll hear more about the digital twin.
Thanks, Kate. That's brilliant. It's, I mean, it's a huge amount of partners that you work with, and a massive amount of data that you're pulling together for people. And I think it's all the work is reflected in such an impressive number of users. So yeah, thanks again, and recommend anyone who hasn't looked at the portal before to check it out and go and have a look on there, because there's a huge amount of data available. Okay. So we've heard about in situ data from Kate. So now let's hear about how we monitor the oceans from space with my colleague Joanna Brito, who's Earth Observation Support Specialist at EUMETSAT.
Thank you for the introduction. I'm going to share my screen. Okay. Okay, thank you again. So good afternoon, everyone. It's a real pleasure to be part of this Ocean Decade webinar series. Today, I would like to share with you how EUMETSAT is helping us to monitor our oceans from space, and how this continuous stream of satellite observation is actually contributing to improving our collective understanding of how the oceans work and how they are changing. So my colleague Haley has already introduced in previous webinars the work that EUMETSAT does, but just as an introduction, EUMETSAT is the European Operational Satellite Agency that is monitoring the weather, the climate, and the environment. So you might not have heard of EUMETSAT directly, but especially if you live in Europe, you have certainly interacted with our data. And this is because the vast majority of satellite products that feed the Europeans' weather forecasts and predictions, they actually come from us. So at the heart of EUMETSAT are the mandatory meteorology programs, but our work actually goes beyond meteorology. And we operate and support optional programs that are dedicated to the ocean and the climate monitoring. So we talk, for example, about the JSON altimetry missions, which have been crucial for measuring the global sea level, and more recently, the contribution of EUMETSAT to the European Union Copernicus Programme. And in this context, EUMETSAT has been responsible for operating the ocean monitoring missions Sentinel-3 and Sentinel-6. So these satellites, they carry a suite of sophisticated instruments that measure with high precision the sea surface topography, which help us to track ocean currents, tides, and the global sea level, but also the sea surface temperature and the ocean color. And from 2026 onwards, EUMETSAT will operate, process, and disseminate data from new Copernicus missions, which will include the Crystal mission, which will be dedicated to monitoring ice sheets and sea ice, but also the next generation of the Sentinel-3 and Sentinel-6. So the EUMETSAT's past, present, and future missions, they ensure one thing above all, which is a consistent and reliable system that is capable of monitoring not only the weather, but also the climate and the oceans. So consistency and reliability, these are the key ingredients for the sustainable expansion of the global ocean observing system, which is precisely the focus of Ocean Decade 7, challenge number 7. So we are calling for a sustained, integrated, and accessible observing system that is going to serve the needs of science, policy, and our society. And this is exactly what EUMETSAT attempts to make a key contribution. So if we focus, for example, on the sea level, which is one of the most important indicators of climate change, we have been tracking over the last 30 years, we have been tracking the sea level with the radar altimeters, and all of these efforts started in 1992 with the TOPEX Poseidon mission. And since then, what the data has been showing is actually a rise in the global mean sea level of about 11 centimeters. But even more concerning is that in the past decades, the sea level has been climbing at about 4.2 millimeters per year, which is roughly double the rate that has been measured back in the 1990s. So as a result, we are now also capable of computing the acceleration of the sea level rise, which currently stands at about 0.2 or 0.1 millimeters faster each year and every year. So this, my message here is that our ability to detect both the rise but also the acceleration is only of this variable, the sea level, is only possible because of the continuity and the precision of the reference altimeter emissions. So initially the TOPEX Poseidon, followed by the JSON 1, 2, 3, and now the Sentinel-6. So each of these satellites were carefully cross-calibrated with the Perseid's satellites. They were launched on the same orbit, and all of these ensures that a seamless long-term record of sea level that scientists and our policymakers can actually trust. So later this year, Sentinel-6B will take over to ensure that this vital climate record of sea level continues. And therefore, all of this effort will help us to support the sustainable growth of the global ocean observing system. Now, moving into the challenge number 8, which tackles the creation of digital representations of the ocean, I would like to share with you the contribution of EUMETSAT to the Digital Earth Architecture Storytelling Service, where we tracked the journey of the iceberg A23A using Earth observation data. So this iceberg is no ordinary. We are talking, as some of you might know, about the largest iceberg in the world. And this iceberg calves from its main ice shelf in Antarctica more than 40 years ago. And today is grounded on the seabed near the south of Georgia. So this journey has been long, and Earth observation has been key to understand how it has moved, how it has changed, and what might happen next. So, for example, we use visible imagery from the All-Sea instrument, which is on board of the Sentinel-3, and this instrument provides daily views of the iceberg. So we can track its path all the way from the Weddell Sea towards south of Georgia. But because the All-Sea instrument relies on visible light, the observations become very limited during the long polar winter nights. So to complement this, thermal imagery from the radiometer that is on board of the Sentinel-3 captures the heat signature of the iceberg, as we can now see on the video. So it can do this even in the dark. So we're using this technology, we are capable of continuing monitoring the positioning of the iceberg even when the optical sensors cannot actually see it. But beyond the direct imagery, there are also derived products that explain the journey of the iceberg. We use, for example, sea ice drift data and ocean current information, which is showing us how the currents in the Southern Ocean are changing and contributing to the motion of this iceberg. So the story of this 823A iceberg is just one example, but it illustrates quite well the power of combining multiple satellite instruments and products to create a digital narrative of the ocean and the cryosphere in motion. But this is, of course, just part of a larger history of the sea ice change in Antarctica, which can be captured more broadly using the sea ice extent index that has been produced by the EUMETSAT OCCEF. So now moving to challenge number 9. This challenge highlights the importance of ensuring that everyone has the skills, the knowledge, and the opportunities to use ocean data. And at EUMETSAT, we have been contributing to this in two main ways. Especially capacity building and outreach, and also through accessible data tools. So we produce user guides, data application guides, case studies that show and make the satellite products easier to understand and to apply. So these are freely available at the user portal of EUMETSAT, and I definitely invite you to search for some of them. And apart from this, we also deliver a wide range of training programs, most of them online, but also some in person. And a key part of this training is the use of Jupyter notebooks, where we provide an interactive and ready-to-use coding examples that can then be used and adapted for your own applications. Then to make sure that the data is not only available, but is actually usable, we also provide a suite of other services. Namely the EUMET View, Data Store, and Data Tailor, which allow you to visualize the satellite imagery, download it, and customize it if you wish. And in this context, we have also developed EUMDEC, which is a Python library that enables a programmatic access to the data. So you can systematically integrate the imagery information into your workflows and applications. So together, all of these training efforts and tools, they empower the users worldwide to turn the satellite information into knowledge that supports not only the science, but policy and the society. And finally, the Ocean Decade calls to reconnect the society with the ocean, and we think that satellites can help. At least we have seen this firsthand at EUMETSAT. We have collaborated with journalists to bring ocean stories into broader audiences. We have supported public events where people experience the satellite data in many new ways. For example, our colleague Haley has been involved in projects turning data into poetry, music, Lego models, and cake. And these initiatives, they show that ocean data can create new bridges between the society and science. So my closing message is, let's collaborate. We believe that working together, we can use Earth observation not only to understand the ocean, but to also deepen our connection with it. And that's it. Thank you so much.
Okay, thanks a lot, Joanna. That's great. I really like that iceberg animation. I need to see it again. Okay, so we've heard about ocean data, in situ data, and satellite data, and how it's been collected. And now we're going to hear about how it's modeled to develop insights and produce services. So we're very lucky to be joined by Maureen Delorme, who's Capacity Development Officer at Mercator Ocean International.
Thanks, Neil, for the introduction. Hi. Hello, everyone. Let me share my screen. Okay, you should see my screen now. Okay.
Yep, good.
Great, thank you. So yeah, hello everyone. I'm Marine Delorme. I'm a Capacity Development Officer at Mercator Ocean International. And today I'll be talking about modeling our oceans. So you've just seen how EMODnet and EUMETSAT provide valuable in situ and satellite observations. To turn these observations into a fuller picture of how the ocean works and how it's changing, we need to model it, and that's exactly one of the roles of Mercator Ocean. So what are ocean model products? An ocean model is essentially a mathematical description of the ocean in 4 dimensions, the 3 dimensions of space plus time. By combining these equations with other observations from satellites and in situ instruments, the models can tell us what the ocean looks like today, forecast the next 10 days, and even reconstruct past decades through reanalysis. They let us describe the ocean from the surface all the way down to the seabed, creating a digital picture of the global ocean. Through the Copernicus Marine Service, Mercator Ocean International operates around 100 numerical models to make this comprehensive view available to everyone. So our model products fall into 3 main families: forecasts that predict the ocean's evolution, analysis that describe today's condition, and reanalysis that reconstruct past decades. This model would not exist without observations, so satellite and in situ measurements are essential to build them, to feed them, and to validate their outputs. Each product is continuously checked against observations, and a quality information document is available on the Copernicus Marine website on each product page with validation results and improvements over time. This way, we make sure that the information we provide is both reliable and scientifically robust, helping to guide decisions about the ocean. Our model products operate at different scales. Global models are coarser with resolutions between about 25 and 8 kilometers, 50 to 75 vertical layers, and daily outputs. We also have regional models for regional seas that provide much finer detail, down to 1 to 3 kilometers, and in some cases, hourly forecasts. And we also have wave models ranging from 50 kilometers globally to about 10 kilometers regionally. Global products give us the broad view of the ocean, while regional ones provide the detail needed for coastal and operational applications. Together, they cover the full ocean systems, described here in 3 dimensions: the blue ocean, which represents the physical state with variables like temperature, salinity, and sea level; the white ocean, which focuses on sea ice, including thickness, extent, and velocity; and the green ocean, which represents the biogeochemical system with variables such as nutrients, oxygen, and phytoplankton, for example. Our model products support a wide range of blue economy activities, from marine safety and offshore operations to aquaculture, climate monitoring, and coastal risk management, for example. And by working hand in hand with satellite and in situ observations, models add the detail and the continuity that's needed to make this information truly useful for all these sectors. Through the Copernicus Marine Service, we support all of these communities, and on our website, you can explore the marine variables and the benefits they bring to each one. All the Copernicus Marine model products are freely available through a single access point. which is the Copernicus Marine Data Store at marine.copernicus.eu. Once registered, you can access nearly 300 products, including about 100 models, all harmonized in NetCDF format. Alongside models, Copernicus Marine also provides satellite and in situ data, but processed at different levels than what you find directly on EUMETSAT or EMODnet platforms. Some parts of the EMODnet and EUMETSAT catalogs are included here, although not all of it. For example, EMODnet's human data is not. And so that's why these three services complement each other, working together. And all together, they give us a more complete picture of the ocean. I also just wanted to mention that on the Copernicus Marine Service website, if you go to the user corner, you can find a range of material to help you use the data. So we organize a lot of training events for which you can find the replays on this user corner. You can also find a lot of Jupyter notebooks to help you start and use the data. So I really encourage you to visit this user corner to find about all this material. And to finish, I would like to show you an application that was developed for the United Nations Ocean Conference that happened in June this year. So the objective of this application was to show decision makers that investing in ocean observing systems is essential for accurate and reliable models and for predicting the ocean in a changing climate. So in situ and satellite data are not only vital for monitoring, but also for feeding models like the 3D Global Ocean Analysis and Forecast System, which is one of the most widely used Copernicus Marine Service products. Assessing the impact of current and future observing systems help us measuring their benefits, identify gaps, and prepare for future missions. So I will just now quickly go to the application I just mentioned, which is here and that you should now see. Okay, so the objective of the observing system experiments that you see on the screen was to illustrate how the number of satellites impacts the accuracy of ocean models. So the example here shows daily sea surface current forecasts in the Gulf Stream. On the left, the model uses 3 altimeters, while on the right, it uses 6. And as more observations are added, including those from SWOT, the SWOT satellite that I'll add in a minute, we can clearly see sharper and more coherent fronts, such as the Gulf Stream path, and as well as EDs with more realistic shapes. So for example, if you look here at the bottom, you can see that the location of the ED actually changes with the addition of more satellite observations. And this shows that this improved accuracy has very practical impacts. For instance, more precise forecasts make it easier to conduct search and rescue operations by predicting the drift of a vessel. And so the key message here is very simple. Models cannot exist without observing systems, and continued investment in these systems is essential. So that was all for me, and thank you very much for your attention.
Thanks, Marine. That's a great message to end on, and I really like that animation as well. So thank you very much. Okay, so I think now we've got a bit of time to go to some of the questions that we've got in Slido. So hopefully we can show these and I'll be able to see them. Cool, good. Okay, So I'll start with this first one. When you talk about ocean observations, do you include citizen science observations? And if so, how? Is it a priority? I think because Kate mentioned about citizen science in her presentation, maybe you could answer this one a little bit.
Absolutely, sure. I can kick off and then others, of course, add as well. You can also see a reply in the Slido for clarity as well. So EMODnet absolutely collaborates and increasingly partners with citizen science. So we're talking here a very broad range of where society is involved in the data collection activities. So it could be anything from a beach clean where they're collecting quantitative information to assessing images of deep sea animals. It could also be where ocean sensors are fitted to platforms of opportunity where you have, say, recreational boating or yachts that are fitted with sensors. So that's going a little bit beyond citizen science. It's more participatory science where you've got really scientific grade automatic sensors that are, taking observations. And EMODnet works with these partners first to support them to release the data and work with them to standardize these data, but then as a feedback to also give advice on how to harmonize the data collection process. So making more standardized metadata, how we describe the data, for example, making it more harmonized so that it's ready to integrate into EMODnet. And that just helps with the data pipelines to make sure we can accelerate that data sharing and integration into the services.
Mm-hmm. Okay, thanks, Kate. Would any of the other panelists like to add to that, or? Nope. Okay. No, it's interesting, and I guess it ties in with the aim of getting people more involved with the oceans and feeling more involvement. So the more we can all support these citizen science projects, the better, really. Okay. So then there's another question. Yeah, regarding the public-private partnerships, with which industries are they envisioned, and are collaborations with startups? How are collaborations with startups fostered? I think this might have been directed towards Pierre-Yves, maybe, or if anybody else would like to answer. Because I think, Pierre-Yves is still there. Pierre-Yves, would you like to answer this one?
I put an answer in there, a written one there.
Okay, Louis, you've answered, yeah.
Yeah, just
okay. Yeah.
Yeah, just to say specifically around this concept of data sharing, at least in the context of the Ocean Decade, I would say it's industry agnostic, right? We want to try to share as much ocean data as we possibly can, but at the same time, we don't, because our time and resources are limited, we also don't want to just share anything. So one of the exercises we went through at the beginning of the group's efforts was to sit down with a group of scientists and kind of have a dialogue. What are some of the key data sets that you need or that you see that are missing that would be very valuable, etc. And then we tried to combine that with, well, what are some of the data sets that are typically acquired by these different industries, and that's kind of why we came up with bathymetry, some form of biodiversity data, which ended up being marine mammal observations. Yeah. And then we're currently trying to figure out which one we want to do in the physical oceanography side. But CTD data seems to be one, again, that's commonly acquired by private sector, but not shared. So it's not necessarily specific to an industry. I'd say it's more specific to specific types of ocean variables that we focus our efforts in this context.
Okay. All right. Thanks, Louis. And I can see Pierre has also put an answer in there that people can have a look at. There's another question there, which I think is more towards you, Louis, while you're on. It's how many countries have adopted the policy recommendations that you were talking about, and what types of data are recommended for mandatory sharing?
Right, so the policy recommendation was adopted by the IOC Assembly in June of this year, so it's quite recent. Again, it's a recommendation, it's not something that's mandatory, so now we need to do some lobbying to get certain countries to look at that. But we did use some existing examples of countries who have done that. One of them is the UK through the Crown Estate. Any permit that a company requires to build an offshore wind farm, to lay a cable, needs to go through them. And one of the conditions in order to obtain that permit or that license is that you share any and all data via the Crown Estate, which then puts it onto their marine data platform, and then that is connected with other platforms like MEDIN and EMODnet. So it's a great way to share the data. So Norway also has something in place, and it is, I guess, it's all data that is collected in the process of designing, building, and operating that particular asset in the ocean. So it could be geophysical data, it could be geotechnical. It's data on time series of wind speed. Also marine wildlife observations, whether it's birds, mammals, or other wildlife. So there's quite a variety of data collected there and shared through those systems. And what we want to do is to try to replicate that model in the UK and Norway in other countries. Right? Yeah.
Okay, that sounds good. So we're back to EMODnet for quite a specific question, I guess, for Kate. From EMODnet, can we download time series for a point, line, or polygon drawn on the map?
Yes, there are some time series. It's not every single of the 68 parameters, but they do exist indeed. I would add that EMODnet is not a GIS service, though. So if that's what you're looking for, that's actually something that the European Digital Twin will be offering. But yes, there are some time series. And if you're interested in specific ones, let me know and we can put you in touch with the right expert to advise you on that.
Yeah. Okay. And then we've got another question here that's what are the differences and overlaps between the data served by EMODnet and Copernicus Marine Services? Maybe Kate?
Gary, yeah? You and me.
I can start if you want, and you will complement. I mean,
okay.
I mean, first, important to explain that those two services are really coordinated together, just to make sure that they complement each other. On we have the Digital Twin Ocean, which is a over umbrella. But very briefly, I mean, Copernicus Marine is using in situ satellite observation and model for ocean monitoring and forecasting. The in situ part of Copernicus Marine is done in very close relationship with EMODnet. So EMODnet is really the backbone for in situ observation on data. We have activity in Copernicus Marine for in situ just to make sure that we prepare in situ data that are required to feed our models, but we cooperate for the in situ component. I mean, for example, the physics and EMODnet and Copernicus really work together on there is the to make sure that we process the in situ data in the right way. Then in Copernicus Marine, we have all the satellite thematic assembly center for sea level, SST, sea ice, ocean color, and the modeling and forecasting center. So in brief, they are very complementary. We work together very closely, I mean, since the start. This is managed in 2 different DGs in European Commission, but we now have also with the European Digital Twin Ocean, excellent work which has been done just to bring together these two services for the user community. Up to you, Kate.
Yes, I'll only just add then that a couple of years ago, the Mercator Ocean and so the Copernicus Marine and the EMODnet teams, we did a joint communication on this because we do appreciate for those less familiar, it can be a little bit confusing. So there is a communication I'll put in the chat now where you can read more about the complementarities. But in a nutshell, EMODnet only does in situ, but it does a wider diversity of in situ. So that's the point I would make here, that it brings together not just the oceanographic, but also the marine geological, bathymetric, human activities, and across the board of the marine environment. So I think that's where the different complementarities lie. And all the data, both satellite and in situ, is critical, of course, for the digital twin and for other applications.
Yeah. Okay, thanks, Kate. But don't go away because we've got one last question. What's the data accuracy and or resolution of the EMODnet bathymetry data?
Now, without knowing if there's a bathymetry expert from EMODnet on the call, I can make an overview, and then again, I would suggest you contact our help desk and we can give you more specific information. We have a digital terrain model, and that has a 100 by 100, 115 meter resolution at the equator, so that's obviously going to change. We do have even higher resolution, but it's not across the board for European seas, and we're working, with different partners like Fuga in the private sector, like research and other surveys to increase the resolution of the in situ.
Okay, all right, brilliant, thanks.
And just to say, it's specifically not intended for navigation, so it's really a foundation baseline bathymetry for building applications on top, or for research, for policy applications, etc. So that's an important clarification, I would say.
Yeah. Okay. All right. Thank you. So that, I think we've come to the end of the questions for now, and we've hit everyone with a lot of information there. So I think it's probably a good time now to have a coffee break. And so we're going to break until 3:35. So that's 10 minutes from now. And afterwards, we'll have the digital twin session, and we'll have the ocean literacy and citizen science session as well. And my colleague Angeliki will be moderating that, so she'll take over from me. And thanks again, all the speakers, and see you in 10 minutes.
Okay, welcome back, everyone. Thank you for rejoining us for the second part of our webinar. My name is Angeliki Karampourouni. I'm leading communications for EMODnet. It is a pleasure to be here today, presenting the second part of this webinar. We've had some really great presentations so far, and for the second part, we are going to see presentations on the digital twins of the ocean, as well as ocean literacy and citizen science. These are both topics that have already been touched upon by previous speakers, which goes to show what important components they are for the European marine community, but also, of course, the international community. We're going to hear for this first part on the digital twin of the oceans from Zoe Constantinou for the policy perspective, a policy officer at DG Mare, as well as from Fabrice Messal, who is User Experience and Capacity Development Manager at Mercator Ocean International, and he will speak to us a little bit more about the applications on the EU DTO overall, both quite knowledgeable on this subject. So in order to keep also with the time, I'm going to give the floor directly to Zoe. Zoe, please, if you can start your camera.
Hi, Angelica. I have opened my camera. I hope you see me.
Yes.
Start sharing my screen if you would like. Now. So let's go at the beginning, maybe. And here. You let me know if you can see things nicely.
We can see things very nicely.
Very nice. Thank you for having me today. I jump directly to the topic of the European Digital Twin of the Ocean and go a little bit behind the vision of the European Commission, so the policy perspective of developing the European Digital Twin of the Ocean, and how, by using the European Digital Twin of the Ocean as the final objective, we build better our overall policies around marine knowledge in Europe, hoping also to have a contribution to the global landscape. So this year, during the Nice United Nations Ocean Conference in June, President von der Leyen used the opportunity of unveiling the digital twin during the conference, but also the opportunity of the announcement of the Ocean Pact as a framework policy for oceans in Europe, in order to also announce the Ocean Observation Initiative as an ambitious initiative that will try to bring all marine knowledge together. The center of this initiative is the delivery of the European Digital Twin of the Ocean, which aims to bring together all the available knowledge that we have around the oceans and all the investments that the European Union has been doing during the last 25 years in developing this knowledge in one place, and enhance it and create the tools and the opportunities and the applications and use the technologies in order for this knowledge to become actionable. Actionable not only by research and innovation, not only by modelers and people that are developing other forecasting applications, but by everyone, by people in businesses, by people in policy, by people in society, in order to address challenges that are related to the environment and the climate, in order to address challenges that are related to the competitiveness of the blue economy, to the sustainability of the blue economy, to the protection and conservation of biodiversity and its resources, and in order to better implement European policies that have these overall perspectives in mind. If we want to have a platform that will bring all this knowledge together, this knowledge that is valuable and extremely useful for different developmental challenges, we need to have a marine knowledge value chain. And this marine knowledge value chain starts in ocean observation, continues in data, and only on top comes to the knowledge delivery through applications like the European Digital Twin of the Ocean. That is our crown jewel. So a little bit about the Ocean Observation Initiative in very short words and high-level objectives. What do we want to do in order to go towards our final goal? So the first high-level objective is the establishment of a fit-for-purpose European ocean observing system. This has a number of sub-challenges behind it and a number of sub-objectives behind it. A very important one is the strategic autonomy and leadership opportunity for Europe, where we are in a condition that we are realizing that ocean observations globally are being under threat. There is underfunding, there is undercommitment into global ocean observing, which is affecting different kind of applications that are very relevant for marine knowledge and in the end for the digital twin. And this cannot be left without a solution. So this is an opportunity for Europe to step up in its obligations towards the global observing system. Another part has to do with the development of the research and innovation and the technology that is required for observation, with parallel enhancement of the European market for ocean observing technologies and for other technologies that are related with marine knowledge. And in the end of it, there is a very important component of the ocean observation governance and coordination across the member states and between the member states and in each member state on itself. This has been a request for the marine knowledge community for many years, and now it has an opportunity to come forward through a very well-structured inter-service approach in the European Commission. The second high-level objective is the optimization of the European marine knowledge value chain. The European marine knowledge value chain is the foundation in which the European Digital Twin Ocean is being built. Our legacy asset knowledge services, Copernicus Marine and the European Marine Observation and Data Network, but also other components that are related and other services that are related with regulatory data, as for instance is WISE Marine. Through this approach, we want to create a unified and well-governed marine knowledge value chain that is going to support the European Digital Twin. And finally, behind the third high-level objective of the Ocean Observation Initiative is the delivery of the operational Digital Twin Ocean as a public service for the European citizens and beyond, and building on large digital developments and artificial intelligence capacities that will be provided by other Commission programs. Now, the European Digital Twin is supposed to be a platform that will bring together our basic marine knowledge capacities and will enhance them in the most innovative way in order to be used by everyone. There are a lot of challenges for the future. We have been working in the development of the European Digital Twin for a number of years now. And currently we have a core pilot infrastructure where it brings together our two core services, Copernicus Marine and EMODnet, the data that are provided. It provides the quality assurance of the services, and it starts developing a number of other services for the users. We are at the beginning of the second phase of development for the European Digital Twin Ocean Core Infrastructure, EDITO. And there are three challenges for the future. There are challenges that are related with how we share information in a reliable and relevant and scalable manner. Challenges that are related with the infrastructure and the technologies behind it. Some of these challenges are thematic in our community, but some other challenges have to do, as I said, with the digital developments that in which we need to build and we need to capitalize on and take advantage of in the European Union. And the third challenge, maybe the biggest one, is the one that is related with impact. How are we going to make the European Digital Twin Ocean very relevant for different users, maintaining quality, maintaining certainty behind it and authority behind it, and at the same level, at the same time, developing a number of different applications that can be used by users in Europe and beyond. So this is a consolidation of marine knowledge, and this is a vision that has been doubted by many on its possibility to actually happen. But we have been seeing that month by month and year by year, we are closer to achieving it. There is already a core infrastructure that is that you can visit, that you can use, where you can have access to data from, and information can be found in the slide. And this infrastructure can offer different capabilities, exploration capabilities, contribution capabilities, and creation capabilities. These capabilities are targeted towards different level of expertise in the different users, and they are developed step by step together with a number of users, and will continue to be developed through multiple actions. What we do currently is that we invest in developing these basic capabilities, but also we invest in using what has been built in Europe through multiple research and innovation activities in the past, and through multiple operational investments in marine knowledge. So the core knowledge that the services of Copernicus Marine bring in are the baseline, and then a number of European projects that have been developed in the past, but also are going to be developed in the future, are the elements of this infrastructure that is built day by day. So each project, it brings its data, the different tools, and it has the capacity to have a front infrastructure and a window to the world, if you want. And this provides a number of opportunities of development of projects with different elements that then can be multiplied into different areas of the world. The vision behind the European Digital Twin Ocean is that will not only become a platform for environmental knowledge. The focus, of course, in the beginning is in environmental knowledge, but the biggest challenge is to bring in the different levels of knowledge and contributions that they can create an actual twin into our real world challenges. And this will require socioeconomic knowledge as well, but it also will require contribution and co-development and engagement of different actors in order to be able to come into full fruition. The digital twin is seen, at least from us, and the level of the European Commission, as an opportunity for the creation of a big mosaic of innovation action, where different people can collaborate and learn from their experiences, exchange tools, combine tools, and have by combining tools, create further added value from this combination. A wide range of applications are currently showcased, and they are slowly integrated in the core infrastructure. And year by year, they're going to become more available for scenario analysis and scenario assessment, and for different level of uses. Before I close, I want to say that this November, at the end of November, we're going to have the Digital Ocean Forum 2025 that is going to focus into bringing in and collaborating with a wide variety of stakeholders in the technical level and in the communication level. And with this, more information you can find through the QR code. Thank you for your attention.
Thank you very much, Zoe. We all know that this is quite an exciting project for Europe indeed. And you showcased, of course, all the technical aspects that are ongoing and are being developed in the background. And Fabrice is going to speak a lot more on this. But also, we are quite excited about the community aspect that is being built around the digital twin of the ocean, which is another incredible component. Thank you very much. And now we're going to give the floor to Fabrice Messal. Fabrice, hello again.
Hello, hi everyone. Can you hear me?
Yes.
So thank you to give me the floor. I will complete this presentation from Zoe about the digital twin of the ocean, trying to show you some examples of the kind of applications and services which can be developed on this nice infrastructure. Because yes, the ocean faces many threats, and we are facing many challenges that require now urgent decisions. And these decisions must be made on the basis of scientific data and all the knowledge we can gather around the ocean. You should therefore view the digital twin of the ocean as a powerful digital infrastructure for international cooperation, informed decision-making. I will show you some examples, and bold strategies for ocean sustainability. And we really want to put science at the service of policy and decision-making to achieve concrete results. So I will share my screen and give you some example of applications we have developed in the frame of the United Nations of the Ocean Conference in last June. This is demonstrators on focusing on different themes and topic to give you an overview of what can be developed on this infrastructure. And again, all these examples I will show you should be replicable, relocalizable, and scalable. And this is really the goal of this platform, because one of the most important words for me is the collaboration around this platform. We need to share the knowledge, but also to contribute and to share all not only the data, but also the developments, the applications, the services, etc., etc. So let me share my screen. Okay. Okay, can you see my screen? Yeah.
Yes.
Okay, nice. So the first application I would like to show you is an application based on focused on the coastal erosion. So there is many coasts which are facing this kind of threats, and some institutions are working hard to find solution and propose solution based on, for example, nature-based solutions. And the idea of this application is to showcase how you can deploy this kind of service on the digital twin of the ocean. And thanks to the simulations behind, hosted on the digital twin of the ocean, you can activate these simulations and make different configurations in order to find the best way to reduce coastal erosion. For this example, we are based in the Wadden Sea, north of Germany. And this is the institution EREON, which was developed the hydrological models behind. And the idea is to test different kind of configuration of seagrass meadows in order to reduce the impact of extreme events on the coast. Okay, so this application, you can choose different positions and density of the seagrass meadows, and you can launch this configuration and launch a scenario and see the impact of your configuration. So let's try one or two different scenarios. So I will start with a upper position and a low density of seagrass meadows, and I launch the simulation. What you can directly see on the application is the results of this simulation. And in blue, you will have the areas where you have reduced the coastal erosion thanks to this specific configuration. Okay. Now, what is it interesting is that you can relaunch many times the simulation in order to find the best solution for your region. So I will make a second simulation with, for example, a middle position, but very high density of seagrass meadows. Then I launch a second simulation, and I can compare now the results of the two simulations. And as, for example, governmental authorities, I can now see clearly what is the best configuration for my coast. So obviously, there is a lot of information missing in this demonstrator, because you can add other kind of social economic data in order to make your simulations and your application more accurate and make the better decision. But this is the first step, and again, this is only demonstrators to showcase the potential behind this platform. Second demonstration, it's about biodiversity protection. So now, for example, we are in the Pacific Ocean. The idea behind this application is to showcase that scientists now are able to create models representing the behavior of some marine species like turtles, because they know that their behavior are driven by some physical characteristics of the ocean and some biological characteristics also of the ocean. So if you are able to combine the temperature, the currents, the food, the quantity of food available on in the area, you can you can design this kind of drifting models of turtles. So I'm going to show you this simulation of turtles. So this is virtual turtles. So we start from the Costa Rica coast. And now we have launched 150 juvenile turtles in the Pacific Ocean. And you see that they are small turtles and they are trapped in a kind of eddy here in the Pacific Ocean. Okay, this is the first step. You can develop different kind of models and simulations. But once you have this kind of information, you are able to create a density map of the turtle at different period of the year. And if you combine this kind of information to another information like human activities, like fishing activities, you're able to create risk map of fishing effort of the turtles. And this is the kind of map you can have. So in red, this is the areas where you have a high concentration of turtles and at the same time, high concentration of fishing boats. So there is a high risk of bycatch of turtles in these areas. And what we are proposing here as a scenario is that as an authority or people in charge of monitoring this kind of challenge, of issue, you can choose to take actions and, for example, close some fishing activities during certain months and see the impact of these decisions. So, for example, I will take action to close fishing activities in January, February, and March. And I can see that I have reduced on this area by 22% the risk of bycatch of turtle. So again, this is just an example of what is possible to do with such kind of platform and tools. The only limit is the imagination of people developing this kind of applications. So what you have to remember about the DTO, is that, as Zoe said, it's not only a tool built for scientists. It's really an open window to the ocean, accessible for all. And to understand that better knowledge leads to better choices, and better choices lead to a better ocean and a better planet. Thank you very much.
Thank you very much, Fabrice. That was a great presentation again. I think it's clear we're already quite excited about the capabilities of the platform currently and all its features, but also the word that you used is a key word. The potential of it is vast. So we are all keeping an eye out for the project and expecting further great things. I think that we can, I'm not sure if we're going to go now directly into the Q&A. Let's get to that and see what questions we have. So they will all be for you, mainly. So what are the practicalities of combining satellite and sea surface data in models that make inferences?
So I can see the question.
What are the practicalities of combining satellite and sea surface data in models that make inferences? I don't know if this is something that also, of course, other colleagues on the panel, if they feel that they have a good answer, they are welcome to open the camera and join.
make inferences. I cannot well understand the question.
If maybe the participant who put this question there could offer us a little bit more context, and then we can come back to it. Let's go to the next one about whether there are or will be pipelines in place that automatically incorporate data from EMODnet and Copernicus Marine into EDITO. Well,
yes, of course. The digital twin of the ocean is built on these two main EU assets, which are the EMODnet and Copernicus Marine Service catalogs. So this is the first part of this huge amount of data available on the EDITO, and the idea behind is to complete this knowledge step by step with new projects, with new additional catalogs to enrich this knowledge basis.
Absolutely, and there is a pipeline, but there's a lot of people working behind it in order to get this to happen. Thank you. And now our final question. Does the Seagrass Meadow tool already use real-time data?
No, not yet. But this is, for example, the next step of this kind of application is to be sure that the processes or the brick developed for this specific hydrological model could be applied in another region and directly adapt with real-time data. But in this kind of application, you want to understand the impact of extreme events, past extreme events on the coast. So yes, you can use to monitor real-time data, but this was not the goal of this application at the beginning.
Okay. Clear. So thank you very much. We don't seem to have any more questions for now, but again, for the first participant with your question on inferences, please feel free to take the time during this next part of our session to add your question again, providing a little bit more context. Okay, so, and it's actually quite a good segue because we have also heard from a lot of speakers how a lot of tools that are being created are meant, of course, to facilitate the work of science and policy, but the overall goal is obviously it has to do with society and improving life close and around the ocean. So we're going to now go to another part, the ocean literacy and citizen science, also quite correlated with everything we've heard before. We're going to start with the European Atlas of the Seas. We're going to hear from Kate Larkin, the head of EMODnet Secretariat. Kate, please, the floor to you.
Thank you very much, Angeliki. And as I am sharing my screen, I'm going to just note that I am giving this presentation on behalf of two colleagues, namely Tim Collart and Natalie van Isseke, who are the leads of the European Atlas of the Seas for the EMODnet Secretariat, who unfortunately couldn't be here today. So in this presentation, I'm going to give some highlights of what the European Atlas of the Seas is, but also how EMODnet's data and other open source data flows into the European Atlas of the Seas for storytelling, for ocean literacy, for education purposes, so that these marine data are not just used for, say, quite technical or professional activities, but can also be used to engage citizens, which also inspires them to also go out and potentially collect data, which will help to fill gaps in the observing system that we discussed earlier. So what is the European Atlas of the Seas? It is a communication tool, an online communication tool of the European Commission, managed by Directorate General Maritime Affairs and Fisheries, so DG Mare. It's a web application and it provides map layers of marine data, of the ocean, of the coast, ranging from the environment through to the socioeconomics, and much more than that in terms of the information on a wide range of marine topics. But this content is tailored for the public, let's say, so it's in layperson's language, it's arranged in societal benefit areas or topics that are easy and inspiring to navigate. And there are lots of other features that I will go into for the public, but also for informal and formal education purposes, co-designed with education professionals, so with teachers as well. It includes a catalogue of more than 275 interactive map layers on a range of the marine topics that I've mentioned. So you can search in an online tool for all the different layers that you are interested in, anything from putting your favorite ocean observation platform in there or societal areas such as blue carbon, climate change, etc. Then I mentioned that it brings together data from a range of providers, and this is really its unique asset. We have obviously the marine data services, EMODnet and Copernicus Marine as the European Union public marine services, but there are lots of other marine repositories, marine data repositories, marine data centers, services out there, and they're operating at lots of different levels, whether it's national, regional, European or global. And we also have services that go either beyond or specialize in other domains outside of the marine data. So for instance, the Blue Economy Observatory, which specializes in socioeconomic data. You have also the likes of Eurostat, but also bringing together different EU agencies, European Environment Agency, the Joint Research Centre of the European Commission, and then also projects and other initiatives that are all contributing data into the European Atlas of the Seas to make it really a melting pot really of information on anything to do with the ocean and the coast and socioeconomics as well. So here you just see some examples. Here, for example, is a sea surface temperature layer for EMODnet, which allows you to zoom into Europe, but also take a global picture. There's always a link to the provider for data access. And then once you go through to that data provider, in this case, it's being provided as a layer by EMODnet, but behind that, of course, are many data collection efforts who are also acknowledged in the metadata when you actually dive into the data. But the Atlas itself does not give access to data. It's merely a sort of shopping window, if you like, and an ocean literacy tool. And then you connect to the official data services to extract the data that you're looking for. In the same way, you have a layer here from Copernicus Marine Service where you have the global mean sea level. And again, there are links directly to those data sets through Copernicus Marine. And then an example, as I mentioned, there are some European projects which are providing layers now. Here is one which is a European Horizon Europe project called Mission Atlantic, focusing on trans and pan-Atlantic ocean basin science. And there were collaborations as well with institutes and organizations across the Western Atlantic from north to south as well. And here you see examples of the yellowfin tuna abundance and distribution. And then in terms of the tailoring of the content for public students and teachers, firstly, the languages in more layperson terms. You have map descriptions, predefined maps of interest in these societal benefit areas. You have map stories, which go into more detail of why these data matter for society. And we have also the different languages, which is crucial if we're going to engage wider society to have information available in more national and local languages. And here we have the 24 EU languages. Then as an Atlas community, once per week, there is a map of the week that's picked out from the large collection. And the team write an engaging abstract and storytelling to, again, communicate the value of these data for society. There's also a map of the month published through the European Commission on this. And then there are articles and new releases and the archive as well of maps of the week. And then the Teachers Corner, which is an ongoing initiative where the Atlas team engages directly with education professionals to design exercises for different year groups and ages. There are some quizzes and games and workshops that have been done online that are now resources together with presentations and posters. And it's really an open and free resource for any education professional or citizen to access. Here's just an example. And then, excuse me, then in terms of outreach, there are many different events and workshops where the European Atlas of the Seas is present, everything from research and innovation days that happened recently that EMODnet and the Digital Twin team were already also at, through to specific ocean literacy events. Just last week, we hosted in Ostend in Belgium, where I'm speaking from today, the European Marine Science Education Association, which had more than 100 marine science educators and communication experts in Ostend. And the European Atlas of the Seas was a key resource being used during that workshop, and hopefully inspiring the next generation of teachers as well. Then there are some new location features. So you have My Locations first of all, which is a really interesting one where you can create your own maps and save those on the system. And then recently there was also a My Notes, which allows you to add your own text annotations to maps that already exist. And as I said, you can save and share these maps, which is really useful for teachers, of course, and for citizens. And then most recently, the team launched a mobile version of the European Atlas of the Seas, which is also really important because if you imagine citizens are not, of course, always in front of computers, they want to be experiencing the ocean firsthand at the coast or in the sea. And if they have their mobile device that they can really check the beach litter or the quality of the water or the wind, so that they can go and enjoy their water sports, then having a mobile device is really, really valuable. So that's it from me again. Sorry to have me twice, but I thank the European Atlas of the Seas team for producing the presentation. Thanks.
Thank you very much, Kate. It is quite exciting to see the increasing uptake of ocean literacy tools that are being created. And we do see that there's more and more interest because indeed the tools are made to fit, they're fit to purpose. So let's see also what lies in store ahead on this topic. We are now going to move forward with our next guest. It is Arianna Liconti. Arianna is not going to be joining us live today, but we do have a great video from her provided by her. And as the title says, collecting data from sailboats, we're going to see Arianna from her sailboat. She is a marine ecologist and content advisor for the Ocean Race Summit. So let's go to the video directly, and then we're going to be back.
Hi, everyone. This is Arianna Liconti from Outby, directly from my boat. I'm very sorry not to be there with you all today, but I'm out sailing. And I really wanted to leave you a really brief story of how outdoor communities, people who are out there and live the ocean every day, they can really be not only the data collectors, the citizen scientists, but also the data users. For the past years, we've been collecting data while doing paddling sports like kayak and stand-up paddleboard, swimming, snorkeling, scuba diving, and also sailing. Outby was born at start through a community of outdoor enthusiasts, which is Outdoor Portofino, a local outdoor center in Liguria in Italy. And it then evolved into all of the ways that these people can be the active data collectors for citizen science projects, and in particular through low-tech instruments, for example, pendants to monitor for seawater temperature and so on. We have been working with EMODnet very closely to make sure that all of the data that these people collect, they can then be shared via EMODnet, and then they can then be reused also for predictions, because as outdoor people, we always look at weather forecast, and the same weather forecast that we look at to plan for our outdoor activities, in which we can also collect the data, can also be informed by the data that we collect, and that can also perfection the safety of our outdoor activities and also the performance when it comes to competition. So recently, I've also been involved in the Ocean Race, global sports event in which sailboats, really extreme sailboats with a crew on board, they do an around the world race, a European race, and then an Atlantic race. So recently, the European race has just finished. And during this race, all of the boats, they had scientific instruments to monitor for different seawater parameters, including also physical parameters. And all of these data are also going in EMODnet. And these variables, they're also very useful for sailors in order to understand how to perfection their performance, and also in just trying to understand where to go. So both for weather and climate patterns. So when it comes to safety, performance, and also future climate and the future health of our ocean, the people who are out there collecting data while they do outdoor sports, they are both a valuable resource, but also end users to really advocate for global participative data collection actions. So thank you so much for listening. Here below, you can find all of the information of the things I was talking about, and hope to hear from you soon. Ciao.
Then we will be joined by Mr. Pierre-Yves Cousteau, the founder of Cousteau Divers. He's going to talk to us about a very exciting Project Remora. And the main topic has to do with diving for science. So we're going to see how citizen science data is currently being collected. Pierre-Yves, please, the floor is yours.
Thank you very much. Thanks for having me and for giving me this opportunity to present my project and my nonprofit. I'm going to be sharing, I don't have slides, but I'm going to be sharing my screen here, hopefully. Great, can you see?
Yes, very well.
Fantastic. Okay, so Cousteau Divers is a nonprofit organization for citizen science, environmental awareness, and marine conservation that I founded many years ago. And 2 years ago, we started a project to involve recreational scuba divers in collecting essential data for the ocean, temperature and depth to begin with, but hopefully in the future we can expand this to more parameters. But as a small nonprofit organization, it's already been kind of challenging to do this because the original vision was to use the dive computers of scuba divers. Every scuba diver uses a dive computer for obvious safety reasons. And these computers record temperature, and I was hoping to be able to centralize this data in order to provide useful information for monitoring the health of the ocean. However, we quickly realized the limitations of this data in terms of the accuracy of the localization of the data, the accuracy of the temperature measurements, the thermal inertia of the devices, many different reasons. And we were forced, so to speak, in order to pursue the vision, to develop our own device. And so we've been, for the past 2 years, deploying these devices, the Remoras, which have a GPS, which divers wear on their shoulder during their dive, and that measure the temperature and the depth with very little latency in order to have as much useful data as possible. So this has been our pilot phase. It is over now. So during this 2 years, we managed to collect quite a bit of data and to demonstrate that this approach was feasible. That here you can see where we've been collecting this data. So pretty much from many different places around the world. As you can see, we're also collecting images underwater in order to help identify the presence and absence of certain species based on scuba diver observations. And in terms of data, during those 2 years, with the devices that we were able to produce and to ship out worldwide, we managed to record almost 1,800 hours of data underwater with a sampling frequency of once every second from all of those places that you've seen on the map just previously. And we ran into several technical limitations with our hardware. This is a big and a technological endeavor for a small NGO, just a couple of us working on this. And so now we're in a phase where we're redesigning our hardware in order to make it more durable and more accurate and more reliable, in order to be able to deploy these machines again with our amazing community of testers, of early testers. These are the Custo dive centers and the Custo divers around the world. These are the early adopters of this approach, and already, without advertising about this, we've had an incredible response from the community. People are talking about this. They've already signed up to join. Hundreds of dive centers are already on the waiting list to receive the new devices, which we're painstakingly trying to get out to finalize and to get to them. So that they can help continue to help monitoring the temperature of the ocean, and hopefully more parameters going forward, as the device is very modular. It's just a data logger, and we're going to be able to add hopefully pH, salinity, turbidity, and things like that to this device in the future. So dive centers can join, individuals can also join. We have some very passionate divers who want to be part of this and who want their recreational activity to have a meaningful impact also for the environment. And so, yeah, that's it in a nutshell. And just so you can see here, this Custo Diver X, by the way, these are our tests that we're doing for the new device, so it's not attributed to any dive center at the moment. But you can see we publish these online in real time. We publish these data summaries that show only the temperature at the surface or close to the surface, because defining the term surface is also technically challenging, and at the maximum depth of the dive, whichever that was during their dive. But yes, on our end, on the database, we can see, with sampling frequency of once every second, the evolution of these temperatures through the water column, identifying thermoclines, and finding things that satellites would not be able to reveal in places where there are no fixed buoys or high precision instruments that could be deployed. Thanks to the power of citizen science and this incredible community that's really passionate about doing this. So that's it in a nutshell, and I'm happy to entertain any questions. There's a lot of things I've rushed over, but don't want to run your ear about things that maybe are not relevant to this particular webinar. So thank you very much for having me, and I will try to stop sharing. There we go.
Thank you so much, Pierre-Yves. It's an impressive, you're doing impressive work, and it might have started as a small NGO of 2 people, but it is initiatives like that have been leading the way towards, first of all, recognizing the passion of all the people around the sea who are active there in a variety of capacities, and how much they want to participate in the data collection process, because they too are start using more and more data, but also to see what the needs are indeed of creating these sensors, and of course trying to make them low cost in order to spread the joy everywhere. Thank you very much.
Thank you.
We understand that the diving community is quite active in all of this, and we're going to hear a little bit more about this now from Frank Schweigert, our next guest, the founder and director of the German Ocean Foundation. And he's going to present a little bit more on SSI, the Scuba Schools International. Frank, please join us.
Yeah, I hope you can hear me.
Clearly.
That's very good. Thanks a lot. Unfortunately, I'm at the airport in Zurich at the moment, and I hope everything will working fine. So I have a lot of slides. So we go to the next one. Everything started in my career with a boat called Aldebaran. It's a research and communication vessel, and we did a lot of expeditions in North Sea, Baltic Sea, Mediterranean, also elsewhere, because you can bring the boat everywhere. And with this boat, we are very closely connected to the water sport community. But before talking about the project, I want to take the opportunity and talk a bit about my initiatives in the European Mission Board for Ocean and Waters, because at the moment we are really in a kind of emergency after the conference series in Nice and Monaco was very happy about. And on the next slide, we can see why we need to act now, because everything is about security at the moment. So drones in Denmark, in the airports today and also 2 days ago. And so we need to gain more security. And I think the ocean is the most important basin and ecosystem who could provide security, political security, economic security. There is a big advantage to do more in the blue circular economy. And we also need to take care about our digital security, because 99% is going on satellites, energy security, infrastructure security. You know, everything is very important now. And we need to act now, especially in Europe. And it's on the next slide, some tasks. Maybe I can share these slides later with you. And as a biologist, I want to talk about a bit of philosophy I also want to share with you on the next slide. You can see that all the nature-based life is based on cycles, on not neutral, on environmental and on nature-based cycles. In the next slide, we can see the 4 big cycles on the planet, which is the water cycle, which is the carbon cycle, the material cycle, and the nutrient cycle. And if we want to make good policy, we have to do our business, our activities along these cycles. So this is from the natural science part. And the next slide will show a very amazing woman, which is Elisabeth Mann-Borghese. I was a friend of her and very honored to be. And she told us the ocean will force us to collaborate, and the ocean is a laboratory of humankind. So this time is really now. And I think we need to think about how humans can share the ocean in a more sustainable way. It's on this slide from our ocean book. And then I want to tell you only some of the projects of the German Ocean Foundation on the next slide, because we want to have a dialogue between science, society, business, and politics. For example, yesterday we had a really wonderful discussion in the German Parliament. It's very, very difficult to bring the ocean to the Parliament, but now in times where we need more security, I think the ocean can play a major role. We are very, very active in the United Ocean Decade. So we have 3 contributions and a lot of projects going on. And I will focus now on our main projects, and I want to share and also invite you to them, which is the Love Your Ocean initiative. On the next slide, taking place in Düsseldorf at the end of January. This is a place of around 1,000 square meters. And if you have any projects, any idea, anything presenting on the stage, anything presenting on the booth, you're more than welcome to contribute. On the next slide, we see also a project I like to share with you, because this boat, Aldebaran, is also carrying out a national competition for young people. And probably we will find some money also to go to other countries, because I think to invite young people to be fascinated by the ocean like Pierre-Yves, your father, does, and I was very inspired by him, is a crucial thing we need to do now. And so maybe you have some ideas. We also have a series of exhibitions for the ocean decade. This is the only German place where you can look and feel this decade. It's in Hamburg. So when you come to Hamburg, in the center of Hamburg, in the middle of the harbor, you can find this exhibition. But this exhibition is the leader of a whole movement with other museums and exhibitions as well. For example, the Oceanographic Museum in Monaco is part of this movement. Then several sea life centers. So if you want to be part of this, welcome. Now I want to go to our citizen science project, which is really similar with the one of Pierre-Yves, and I agree that the accuracy of the dive computers are not perfect, but because the ocean is really in danger and massive heat waves are going through, we have a kind of data sharing with Scuba Schools International. So they provide us with about 10 million data from dive profiles, and we put all this data to EMODnet to make it public. So it's a kind of data donation, more or less, and the data are neutralized, so they don't come with the name. But if the diver want, they can put their Insta or their social media name inside, and then on EMODnet later, not today, will be visible these data under this name. So I'm very happy about EMODnet as well, and thanks, Kate, for this wonderful collaboration. I think this is really, really a great opportunity for citizen science, because on the next slide we see that there is a call for action of Europe that about 20% of the marine data should come from citizen science by this year. So I think we need to hurry up. So some takeaways on the next is that we really then we are working on an app for water sport enthusiasts at the moment, and concretely tomorrow we will have an appointment on the trade fair in Friedrichshafen to talk with all the organizations from the water sport industry to create maybe one common app, and one part of this app will be a citizen science tool directly linked to EMODnet. Yeah, so the takeaways is we need to, Europe has a big chance to work now for the ocean, because we have a lot of data, we have a lot of knowledge, and our EEZ, the exclusive economic zone, is the biggest one. And we are very closer connected to the ocean than many people think. And we really urgently need to raise awareness. So that's from my side. Thanks a lot for your attention.
Thank you very much, Frank. It's you really covered a very diverse amount of topics on this specific topic. So the fact that also you mentioned you put it in your presentation the security aspect and how current this is, and we can see indeed how the diverse opportunities for solutions that the ocean gives us. Of course, if we treat it correctly. And again, we see also the many actors that are coming in from a variety of different communities close to the water, and their enthusiasm for collaboration is what is making this possible. There are news that will be coming out in the next few weeks and months of exciting new projects that have to do with citizen science. We're going to try and help all of these initiatives in harmonizing their data and bringing in the data that is needed in the format that is needed. It will take some time, but everyone, I feel, is currently in the right direction. So we expect to see great things. Thank you very much, Frank, as well. Just to mention it again, it has been mentioned before by Neil, but all of our speakers are going to stay with us until we kick off the Q&A, where they will be able to answer all of your questions live. We are now going to go to our next speaker, Natalie Fox. She's a communications consultant and coordinator of Citizens of Surf. I'm very excited about this. I had the opportunity during UNOC to participate in a surfing data collection event, so it was really nice to see that. Natalie, please, the floor is yours.
Okay, I'll just attempt to share my screen and
perfect.
Okay. Yeah, so I was also part in this workshop in UNOC as well. So it's really great to hear all of these amazing initiatives about data, but I guess this presentation will bring it back to the ocean and bring it back to people and their relationship to the ocean. So my project and my background, first and foremost, is that I'm a surfer. So that's my kind of starting point. And I just wanted to make the claim about surfing. It's really not a lot about riding waves. It's about 10% if you're lucky. Most of the time you're spending looking at waves, trying to figure out when to go surfing. A lot of it is actually looking at the forecast. So a lot of it is interpreting data, which is really where this whole idea of bringing surfers and data together has come from. Along the road, I've had some amazing mentors and people to support me in the idea. And I just wanted to bring in some words by Angelique Pouponneau, because she's also been part of the UN Decade of Ocean Science. And she's saying that surfers are like human observation systems. And so we are telling the story if something is starting to feel different, and we're always monitoring. So that's also been picked up by a lot of people working in this area. So that was the starting point for Citizens of Surf, to understand that there's 50 million people going surfing. There's a big variation of how people surf. There's different crafts. Some people surf, some people bodyboard, some people do stand-up. There's different levels. There's different amount of time you spend in there. Some people are getting paid. They're professional surfers. Some people are going off to amazing waves in Indonesia, and other people are staying on a more local basis. So there's lots of different ways to go surfing. And Citizens of Surf is about connecting surfers to ocean science and sustainability through the decade, and specifically through Challenge 10, to restore society's relationship with the ocean so that they can actually actively participate in achieving the science we need for the ocean we want by 2030. So we're really looking at transforming surfing into a culture of care and empowering surfers to be actively engaged and involved in not just monitoring, but also the protection and the restoration of surf ecosystems. And so I focused on this for my master's back in 2021 using the social ecological systems framework, because this allowed me to take a interdisciplinary look at how surfers are interacting with the ocean, what are the outcomes, what are the different components involved. And taking that systems viewpoint has allowed us to kind of see what some surfers might be in a mindset of going into the water with more of a exploitative use. They just want to take the waves and that's it. And then other surfers are thinking about how they can actually be involved in making sure that those waves are going to continue to be there for future generations. So there's a lot of work that went into that. I did a whole paper on it, and to put it into like a little bit of a simplified presentation, we ended up finding out and focusing on 3 of the ocean literacy principles that were most prominent to surfers, that they most agreed with, that they most felt were most true, which is weather and climate, diverse ecosystems, and the human-ocean connection. I found it really interesting looking at the qualitative data as well, how surfing makes people feel, how being in the ocean makes people feel. And then also looking at that gap between, yes, The participants felt that they were connected to the ocean through surfing. However, when it came to actually wanting to sign up to a citizen science program, only 59% would be interested. And when given the opportunity to be part of a focus group and go a little bit further, it dropped again. So it's getting that gap, filling that gap between people who are interested to people who actually want to participate. And so after the research, I've spent a few years working with partnerships and through outreach and basically just testing different ways that we could get surfers involved. And it's really across these three different areas that align also with the decade. So with climate change indicators, so looking at collecting sea surface temperature data. So I'll look at that in a little bit. So Ocean Decade Challenge 5. Marine biodiversity, we've done a pilot using eDNA sampling. So that's also Decade Challenge 2. And then we've been also looking at marine microplastics. And we were lucky enough to participate in a workshop with Surfing for Science, who are doing amazing data collection work in Barcelona. So I did mention as well that when it's not just about collecting data, it's also about engagement. And we saw that this period of time around now, where we've just had the ratification, the entry into force of the High Seas Treaty, this was a really great moment and a really great time to engage surfers in what does global protection of the ocean look like. And this will also lead the way into doing other sort of activities around data collection with them. But I wanted to just say that building that relationship, it doesn't just have to be about data, it doesn't have to be just about science, it can also be about policy and what does it mean when we talk about protection? What are the mechanisms put into place and to kind of get behind that? So it was really amazing to be at a local surf competition and get the kids and the local community involved with that to support the High Seas Treaty. One other thing that we've managed to do is get involved with the World Surf League, and we brought together the commentators who are on the left in this video, in this photo, and with scientists based in Peniche, and they are basically involving them in restoration of seaweed habitats. So they were able to come into the lab, they were able to do the seeding process, they were able to be part of it. And it was really, really quite great to have that first moment in the lab. And a few months later, with some other surfers, we went out with the green gravel that had been seeded in the lab to then place it out into the ocean as well. So having a few months of this project taking place, I think this is 2022. So I also just want to add a bit of a fail in terms of ocean literacy, because I've done a few of these workshops, and I think it's also important to really learn what doesn't work. And I learned that taking surfers or gathering surfers for a workshop and just talking about the ocean literacy principles doesn't really work. Like, we can relate them to surfing, we can definitely say that they're important, but people kind of dropped off. It was a little bit too much like a classroom environment. But I think as ocean literacy and the ocean literacy framework has evolved, looking at the ocean literacy dimensions, this is really helpful in formulating workshops, especially to work with surfers, because actually, when we look at these different dimensions, this is what we can tap into. And this is what we're focusing on going forward to try and bring surfers into data collection and other areas as well. So activism, behavior, attitude, and awareness. So building our workshops and activities around these dimensions. So what's next? So the hope is to actually bring this all together and do a research project where we can focus on collecting climate change indicator data with surfers. And this would be using the living lab methodology. So it would be actually getting lots of different stakeholders in the local area and learning what they would be interested in, introducing some innovative data collection methods and working with them to design something so it would be fully co-designed. So just waiting to see whether this is going to happen in terms of funding. And in the meantime, the project is still happening. It's still sort of self-funded and growing in a grassroots way. So at the moment, we're working with a local surf school. Every day they do a beach clean. And so this has been implemented now for 1 year. And now is the time to get the surf coaches to collect their data and to actually log it. So that is the next challenge. Another challenge, we had like I mentioned, we had a really great eDNA sampling session. We managed to go surfing and collect our sample and then get the results back from the lab. But what happened with those results is that the surfers weren't really that interested. So we managed to get a baseline survey of that surf ecosystem, but funding doesn't allow us to go forward any further because one kit was £300. So we would need a bit more funding to be able to roll out a project like this or a partner who's working in eDNA. And then lastly, I've just teamed up with Jessica Bradford, who is in Nova Scotia. So I'm based in Portugal, in southwest Portugal, and she has got one of these Hobie pendants. So I don't know if my camera's still on, but I have it here as well. And so I actually received this the other day and went out this morning, for the first time to get some sea surface temperature data. And then we will be working together to design something. And Jessica started off by looking at the variation between her temperature reading and the buoy temperature reading, that her closest buoy. And this is what I've done today as well. So as you can see, there is a slight variation as well. So that might be something we would look at going forward, but also I'm thinking that we will be putting out a questionnaire to the surfing community through Citizens of Surf to find out now that we've got our methodology, what is important for surfers to know about temperature, especially heat waves were mentioned earlier. And I think it's also going back to scientists, like what data is going to be important for scientists as well. So great to be able to have this discussion afterwards as well to talk about things. And if anyone wants any more information, don't hesitate to contact me, to be in touch. And thank you very much.
Thank you very much, Natalie. Also great presentation and of course, great initiatives that you have been taking or participating in. I think that our presentations on this section generally, I feel, give us a lot of hope for a lot of things that are happening, but also you can see how everything is so interconnected throughout all of the topics that we have been covering today. Because as it turns out, increased ocean literacy that is being achieved also through such tools as the European Atlas of the Sea leads to more ocean observation, bringing more and more people closer to this notion of citizen science. So again, it's really all one vast community. And we can now go on to our Q&A part. And let's see, we do have some quite interesting questions already. So let's first go with, I'm going to start from the first one. So I think that this is, how is Cousteau divers sharing their data? We see a lot of dive centers in Europe collecting data, but not sharing it into bigger repositories or with local government. So how are you doing this? Of course, I think Pierre-Yves, this is for you.
Yes, thank you. Well, like I said, we're in a very early stage pilot. Our pilot phase just finished, so we're really focusing on collecting this data. And actually, through our exchanges with EUMETSAT, Copernicus, we've also managed to identify what are the needs from the user side. And so we're concurrently to developing the hardware, we're also developing the database so that scientists can access and request specific parts of this data. And I understand also from Ms. Larkin's message that that there are synergies possibly with EMODnet in order to make this data available more widely.
Absolutely, absolutely, yes. We do look forward to this discussion for sure. Thank you. But and we have 2 more questions for you. Have you collected data to understand your participants better? Why do they collect and give data? What are the motivations? I mean, I think we can all touch upon this, but I'm going to again come to you.
Okay, well, I think you know, most people who scuba dive, is probably the same case for surfers, I would assume, are people who have a passion for the ocean, who love the sea, and the reality is that every day, every year, we see the degradation of the natural environment. We hear about the risks and the threats to the sea and to ecosystems, and so I think that is the main driver behind why people are eager to participate in these projects. However, to precisely answer your question, no, we haven't conducted any sociological studies on exactly what are the motivators of why people do this, which would be very interesting, but we haven't had the funds or the team to develop such studies.
Thank you. Well, I'm sure, and I hope that you will soon be in this position. And there's one more, but I think that this is part that you have answered right before. For Cousteau divers, what do you do or hope to do in the future with the data collected?
Yes. So again, we're kind of like an intermediary where we, you know, we're trying to coordinate this community to collect the data in the best possible way and then make it available in the best possible way. We don't currently have any plans to enrich this data ourselves, although there are ideas, of course, of, you know, like everybody and who hasn't been living under a rock, of using AI to generate some kind of meaning out of this data. But I think there are companies out there that are much more well suited to do that than a small NGO. So I think for the moment, we stick to our role of doing the best we can in collecting good quality data and making it available in the best possible way.
Thank you. And of course, this is the most important part. And as mentioned before, there are processes currently being streamlined through the European Commission as well, trying to gather this community and help them improve their processes as well. We are now going to go to a question to Frank. You collaborate with SSI. What about PADI data? Is that also being shared?
Yeah, we are talking to all the organizations at the moment, as well as to PADI, and it will take some time because at the moment we realize the infrastructure with the app of SSI, which is really well developed and has a lot of environmental information as well inside. But this is the idea I showed, that there is a need for a common kind of app for sharing data from environment, from sailors, from surfers, from more divers. And maybe in 1 year, we managed to have an app which is really directly connected to EMODnet to make it easy to to upload the data in more or less real time. So, and if this app is finished, then all the other dive societies and everyone can use this app.
All great plans. Thank you. And we have more questions for you. You mentioned in your presentation that 20% of EU marine data should be citizen science. How is the goal being monitored? And is it a directive, law, or just a goal? What is it for the upcoming 5 years till 2030?
I don't know. I think that Kate could be a better person to answer this question because she's closer to the policy activities of the databases.
I don't know if Kate is still here.
I am here. I am here. I would just note that as far as I'm aware, this really stems from when the mission Restore Our Ocean and Waters was initially published. This is a big ambition of the Commission to engage citizens in ocean literacy, but also as data providers. So there is no kind of formal dashboard or tracking that I know of in terms of being able to track the development of this. It's just been a very good way for us at EMODnet to prioritize, as well as other priorities, but to prioritize reaching out and connecting with citizen science to bring in more data into the system.
Thank you very much, Kate. And I think that there are some more questions that many of our panelists might want to participate in. So for the surfing, but first for this, maybe Natalie, for the surfing citizen science, how are ways to fill the gap between interest towards participation? What are ways that you have seen a successful increase?
Well, I don't think there has been many ways for people to participate in surfing citizen science because it hasn't really been available. There has been a tool called the SmartFin that was invented by researchers at Scripps in California, but it hasn't really made it out onto the market as yet. So I think the availability of ways and workshops and, well, as a surf coach, everyone coming to surfing takes one lesson. So working with a network of surf schools and maybe just integrating just a little bit of ocean literacy or data collection within one surf lesson, I think would be a way. So definitely drawing on the partnerships between surf schools, surf clubs, the International Surfing Association as well. So doing it at lots of different levels and leveraging networks. And then what was the other? Yeah, where have I seen it successful? I think the Surfrider Foundation have had a pretty successful water monitoring initiative where surfers are really looking at water quality as well. So I haven't worked with them directly, but that's definitely something of interest to surfers and connecting human health to ocean health as well. So I will definitely be following up with Surfrider Foundation as well. So yeah.
Great, thank you. It's clear that, okay, there are still many things to do. There's a lot of things happening, but also I guess it's also very clear yet that you're on the right path, that a lot of steps are taken and the effort is there. Thank you very much. So I'm not sure who would like to answer this one, but what are ways to improve funding for citizen science, as this is a big issue, quite a big issue as well, indeed. I don't know if someone from our panelists would like to reply. I mean, yeah, improve funding. It's always a long process, but there are also steps towards. Kate, please.
Yes, I can just add a reflection that I think the data services can play a role here, because eventually the value chain is such, but it can also be a feedback loop. And what I mean by that is that obviously in EMODnet, for example, we are bringing in data, we're acknowledging where the data is coming from, who owns the data, and citizen science is part of that. But if we can work more to have metrics to enable citizen science, to enable all the data providers to track how their data is being used, then it can show the demand for these data, which in turn can hopefully leverage more funding for these citizen science activities. So I think this is part of the solution.
Thank you very much. Thank you. And thank you also, Natalie. We are going to go back to Pierre-Yves and the question on the sensors. So are sensors used by coastal divers being calibrated, different divers at the same moment and location having the same readings?
Yes, thank you. Just before I address that question, I'd like to talk a little bit about the funding, because obviously as a nonprofit, that's a very central question for how we can keep doing our activity for the next 10, 20 years. And I think a lot of nonprofits would like to be self-sufficient, and we are hoping maybe to, and this is not set in stone, but maybe to sell the devices, to have some kind of membership to the association. So we're looking at different ways that we can try to bring in the funding that's necessary for us to continue doing our job. But because obviously sponsorship or things like that are extremely helpful and very valuable, but they're very punctual as well, and it's hard to get a long-lasting revenue model as a nonprofit doing citizen science. To adjust the sensors and the calibration, currently we are using manufacturer calibration values for our sensors. This is a very, very sensitive question for us because we know that sensors drift. We haven't yet been able to measure that drift and to be able to quantify it specifically. Ideally, we would, recall these devices on a regular basis in order to recalibrate them or to measure the drift at least. So this is a very sensitive question, and we haven't entirely wrapped our head around it at the moment. We're just relying on the manufacturer specifications for the calibration at the moment.
Okay, thank you very much. Yeah, I'm sure it takes a little bit of time and work to get to the results that you're really looking for. Already also on a great path. We are going to change a little bit now and go to Copernicus Marine and EMODnet. What are the practical aspects of combining satellite in infrared and optical and in situ data, physical temperature measurements in models that predict variables like eddies in global oceans and ocean heat uptake? I would invite colleagues from Edito, Fabrice, or let's see who is still with us as well. I think Pierre-Yves, maybe you as well, Letraun. Do we have? Yeah, thank you.
Yeah, sorry.
Yes, I already put some elements for the reply or directly on the slide, or because yes, as I said, we can use satellite data we use satellite data to validate our models and to make the models more accurate. And there is many applications after that where you can combine the two kind of informations in order to, for example, geolocalize oil spill and monitor then forecast the drift of the oil spill thanks to the model. But the question of this attendee was more about how to ingest satellite and in situ data into the models, and this is very wide topic because this is a field of data assimilation. When you feed observations into the model, you have to take into account the different timescales, geographical coverage and locations, the uncertainties, etc., etc. So data assimilation is a specific branch of numerical modeling used to reduce the difference between the models and the observations.
Thank you. Thank you. I saw that there was a reply already in Slido, but I thought that this was such an interesting topic and that it would be great if all participants could hear it through the recording. Thanks, Fabrice. I don't think that we have any pending questions for now. We still have a little bit of time ahead of us. So we're just going to wait maybe another 1 or 2 minutes. This has been a series of webinars that we all came together a while ago from EUMETSAT, from ECOP, from Copernicus Marine and EMODnet, and decided to create this series to discuss, to showcase marine data to a wide variety of stakeholders around the world. And we're very glad with how well it was received by users, etc. And so this, however, is the last one. And we hope that it has been very, very useful to you. We do have a couple of new questions. One is, how are the citizen science projects addressing data quality? for this, I would probably invite Kate back, who has been in discussions. I don't know also if Pierre-Yves or Frank would like to address this.
I can kick off for sure.
Thanks.
So absolutely, data quality is really important, and all of the data coming into EMODnet, there is a quality control and rigorous data management process to check the quality assurance, but also then to standardize according to European and international standards to make sure that the data can interoperate and we can make the harmonized maps that EMODnet offers. So once you see it in EMODnet, it's gone through a very long a operational process, let's say, which can take a long time because it really needs specialized expertise. A lot of these in situ data management pathways require highly specialized experts. That's why EMODnet, exists, because it cannot just be automated. So that's the first thing. And second of all, EMODnet works closely with projects which are developing, really innovating the areas of citizen science. There are a number of projects through Horizon Europe and the Mission Ocean which have just started or that are ongoing or finished. And there are new ones that are really looking at the data side of citizen science. There's one called CSMAC1, which is really looking at that data process from citizen science integrating into data services like EMODnet. So I would highlight to sort of track that one, and there'll be more information about this at the EMODnet Open Conference at the end of November in Brussels.
Thank you very much, Kate, which addresses also the next question about whether there will be a citizen science panel at the EMODnet conference in November, and how can you participate at the conference?
Just to say, there'll be a breakout session. So we have a limited time for the plenary, but obviously there will be the in-situation observations are always a very important topic for us. So we will have a panel on this. Not exclusively citizen science, but then there will be a breakout session where any interested data collection effort, especially citizen science, NGOs and private sector, we're inviting to come together to really tackle this dialogue about how to bring more data in also a very structured way that's also very useful for science.
Thank you very much. And on the participation part, I want to mention, because we also mentioned the Digital Ocean Forum, both events are set to open their registrations in the coming 1 week, in very few days. So if you follow the Edito account, if you follow the Copernicus Marine account, if you want to follow EMODnet, we're definitely going to be disseminating the news and the registration links. They are taking place the same week in November, the last week of November in Brussels. And we do look forward to seeing many of you there. Let's again wait and see if there are going to be some new questions. You never know. Whenever you're ready to say goodbye, someone does put a question in, and then, it's not great. So we're going to take a moment. And I don't know also if, again, given that this is the last webinar and there are so many people behind the scenes that have done an amazing job organizing this in the background. So maybe we would also, Neil could reopen his camera. He has been quite an integral part as well.
Yeah, sure. Yeah, thanks, Angeliki. I think all the webinars have been really interesting, and this one's been particularly inspiring and interesting. And I really loved all the citizen science projects. And I think it's been great working with all the partners and working together on this. And I think we should thank all the speakers who've come together and given the presentation. And we also need to thank the Copernicus Programme for funding the webinar series. And then, of course, thanks to everyone that's joined the sessions or watched the recordings on YouTube. Because we've had some huge audiences looking at these recordings afterwards. And also thank you to also Space for helping kind of coordinate and pull everything together. And the final part I would say is that if we can help you in any way, people who are working with ocean data, please get in touch, because we're here and we're really happy to help in any way that we can. because it's such an important initiative, the Ocean Decade, and getting people to work with ocean data. It's so important. Yeah.
Indeed. Great. Thank you so much. We are a little bit ahead of time. We do have still another 15 minutes, but given the fact that we do not have any further questions, and of course, as Neil just mentioned, you're very welcome to connect to all of us. Links have been shared throughout this entire webinar series, so you know how to reach all of our organizations. And we are there to not only inform you, but to actually support you wherever we can. So please do get in touch. Any further questions you may have will also be addressed. And yes, we will put Ari's video online. It will be also made available. It is being taken care of. So I might follow my previous colleagues' way of closing this webinar. I'm going to count back from 3, and if we do not get any further questions, we are going to then say goodbye. So 3, 2, 1. Thank you so much, everyone, for joining us today. Thank you to the speakers. Thank you to everyone. We will be in touch again. You're going to receive an email with a variety of information and follow-ups, and where you're going to be able to find all of this material. Wishing you a wonderful afternoon or morning, wherever you may be, and we look forward to seeing you at another opportunity. Thank you again. Bye.